So next up is the SCS, or Stabilization Control System, Attitude Reference Comparison Check. And this is one that's sort of everyone's least favorite. It's kind of one of those more annoying tests that you do when you get into orbit. But you'll see it's actually not that bad. It just interrupts your flow. You can't go, as fast through this one. Oops, I did not mean to do program 6, meant to do program 0. Sorry, I wasn't paying attention. Verb 06, noun 20. This pulls up our inertial coupling data unit angles, roll, pitch, and yaw, which in the command module correspond perfectly. We'll talk about that statement later when we get to the LEM, because that's going to be an exciting time. We set up our system for comparison, so make sure your scale is 5-1. Not included on the checklist, but trust me, you're going to want it. FDA iSelect will go to 1, so this will turn off the second ball, and you'll set your source to at set. And that'll activate your needles here. And you can see if I had both balls up, it wouldn't activate the needles because it's tied to the computer mode. So setting ball 1 gets our needles up and running. That sets our attitude set ASCP, attitude set control panel box, to the needles here, and we'll set it to the IMU, or inertial measurement unit. We will then set the needles to be centered 180 as told by the down triangle, and then we'll go and we'll match the pitch angle, which is 270. So we bring it all the way around. Would have been faster to go to the other way, but that's okay. And then we also have to remember we're moving on the S4B, maintaining an orbital rate. So our inertial pitch attitude, or pitch angle, is also moving. So we set our roll and our yaw, and when the pitch crosses the center line, hit enter on the computer. That updates the display. And we compare these readouts, 180.24 degrees, 181.12 degrees, 000.34 degrees on roll, pitch, and yaw. We will compare those to the attitude set control panel. And you can see we are incredibly close to those values. These being a bit hard to tell sometimes because there's only the right-clicking moves it by 0.1. So it could be hard to tell with the graphic, but we're very, very close. We'll run that same test on GDC. And if your GDC is slightly misaligned, it's something that you'll have to deal with. Just know that there'll be a little bit of error. Again, wait till pitch needle center, enter on the computer. 180.40 degrees pitch, 277.06, or excuse me, 180.40 degrees roll, 277.06 degrees pitch, and 000.24 degrees yaw. And that lines up very closely with what we've got. There is a bit of a bitmap issue when it flips to 60 like that, so that's just something you'll need to keep in mind when you're looking at that. That's actually not 60 and some change. That's 360 as it rolls over back to 0. Closing out this test, select 1-2, source CMC, attitude set to GDC. Anytime you're not using this for alignments and stuff on the IMU mode, and when you're maneuvering, this switch must be on GDC. There's a systems reason for that. I don't remember it off the top of my head, so I won't give it just in case. But yeah, attitude set control panel. This is a wonderful system that could be used as a backup for the CMC's pointing with verb 49. You could still do verb 49, type in the attitude, get the needles to move, and then manually maneuver. Even on SCS, that'll work. But say your computer is shot, this panel is a great way of getting those angles to go to these needles and then for you to be able to move. And so it's a wonderful backup system for that purpose, as well as its cross-function for interfacing with the gyro display coupler to do the GDC align. The attitude set control panel does not communicate with the IMU. When you flip it up to IMU, she could take, you overlay basically the reference here. But it's not, it's more so integrated with the SCS. I won't say it can't interact with the IMU. It can read from it. It's not as integrated with the IMU as it would be with the SCS. So whenever you're using this panel as a primary mode of operation, you are going to be on SCS. Your IMU is probably going to be shot, and you're going to be using the gyro display coupler as a backup method. So, use cases, overview of the ASCP, and how to do this test. That's all.